divisible by 3 students, because 2 plus 5 plus 5 and that is equal to 12. Okay students, so 12 is divisible by 3 students, so that means 255 automatically divisible by 3. So 255 divided by 3 students. So 3 8s are 24. So here 1, then here 5. So 3 5s are 15. Okay students. So now here we get 85 here. So 85, I write 85 here and 3 here. Now here students, 85 do not divisible by 3 students, do not divisible by 4, but it could be divisible by 5, because we can modify this formula as students, that here LCM, because we have to calculate LCM. So LCM is equal to first number multiplied second number divided by this HCF. Okay students, so this is the new formula, product of LCM and HCF. Okay students, so product is that for product of two numbers. Okay, product of two numbers. Product of two numbers. So which are the two products, two numbers students? 510 and 92. So 510. Hello students, welcome in our channel Class 10 NCERT SSC Math with Sujata ji. Welcome students, welcome in this exercise 1.1 for the real numbers, and this exercise 1.1 is based on the introduction and the fundamental theorem topic. So let us see the example of exercise 1.1. So the first question is express each number as a product of its prime factors. So the first example is 140. Students, you understand what is the instruction of this example. That instruction is that we have to factorize this given number. Okay students, so let us factorize this number. So here first number is 140 students. Okay, so now this way we have to factorize. Okay, arrange this number in this way. So now here in 140, at the unit place there is a 0. So this number is divisible by 2. So 140 divided by 2. So 2 sevens are 14. Here 0 0 and then 0. So here we get the answer 70. So here I write 2. Now here students we have the 70. So now at the unit place there is a 0. So this number also divisible by 2. So here that 70 divided by 2. So 2 3s are 6, 1 0. 2 5s are 10. So we get students 35. So I write here 35 and here students 2. Now here students 35 do not divisible by 2, 3 and it directly divisible by 5. So here 35 divided by 5. So that means here 5 sevens are 35. Okay student. So that's why here I write here 7 and I write here 5. So now here 7. So 7 is a prime number. So I write here 7 ones are 7. So now here finally we write the factors is in the product form. So 140 is equal to 2 multiply 5 multiply 7. Also we can write students square of 2 multiply 5 multiply 7. Okay student. So this is our final answer. Okay, we get the number in the product of its prime factor. Okay students. Now here see the next example. The next example is for 156. Let us see how can we solve it. So 156. Arrange this 156 as this way. Now here see at the unit place there is a 6. So this number is totally divisible by 2. So 2 sevens are 14. Okay. So now here we have the 78. So I write here 78 and I write here 2. Now 78. So 78, in this 78 the unit place number is 8. So that means here it is also divisible by 2. So we have 39. So we have 39. I write here 39 and write here 2. So now 39 do not divisible by 2, but it is divisible by 3. Why it is divisible by 3? Because addition of these two digits is equal to 12. So 12 is divisible by 3. So automatically we can say that the 39 is divisible by 3. 39 is also divisible by 3. So here students 3 3s are 9. So we get 13. So I write here 13, here 3. Now we have the 13 as a prime factor. So 13 ones are 13. Okay students. So now here the final answer, finally we write 156 is equal to 2 multiply 2 multiply 3 multiply 13. That means here students 156 is equal to square of 2 multiply 3 multiply 13. Okay, this way we can factorize 156. Okay students, very easy examples are these. Okay, so now here let us see the next one example. The next one example is 3825. First here we factorize it. So adding this number 3825 such a way. Now here students, the at the unit place there is a 5. So it is not divisible by 2. So check out whether it is divisible by 3 or not. So here 3 plus 8 plus 2 plus 5. And that means here students, that is 11 plus 7, and that will be equal to 18. So now here 18 is divisible by 3. 18 can be divisible by 3. So that means here this number should be divisible by 3. So here 3825 divided by 3. So 3 ones are 3. 0, here 8, 3 twos are 6, then 2, then 3 sevens are 21. Then here students 3 fives are 50. Yes students, it is divisible by 3. So we have 1275. So I write here that number and here I write 3. So now here 1275. So here students 1275. So the addition of these digits are 3, 7, 10, 15. So which is equal to 15, and 15 is divisible by 3. So that means this 1275 divisible by 3. So I divided that 1275 divided by 3. So 3 fours are 12, and then here 0, 0, then here 7, 3 twos are 6, then 1, and then here 5. So 3 fives are 15. So here we have 425. So I write 425 here and here 3. So now we have the 425. At the unit place there is a 5, so it is not divisible by 2. So we check first it is divisible by 3 or not. So the addition of these digits is 4 plus 2, 6, 6 plus 5, 11. So it is not divisible by 2, divisible by 3 students. So and it is not divisible by 4 because at the unit place there is a 5. So directly we can say that it should be divisible by 5. Okay, it cannot be divisible by 2, it cannot be divisible by 3, it cannot be divisible by 4, but it could be divisible by 5. So here 425 divided by 5. So 5 8s are 40, then here 25, so 5 5s are 25. Okay students? So now here we write 85 here and here 5. So now here 85 divisible by 5. So here 85 divided by 5. So that means 5 ones are 5, and then here 35. So here 5 sevens are 35. So here we have 17. So I write here 17 and here 5. So now here 17 is the prime number. So here I write 17. So 17 ones are 17. So very easy. So now our final answer is students. So final answer is 3825 is equal to 3 multiply 3 multiply 5 multiply 5 multiply 17. So that means here students we can write 3825 is equal to square of 3 multiply square of 5 multiply 17. Okay student? So these are the factors of 3825. Okay student? So let us see the next one example. Okay, so now the fourth one example is 5005. Yes, very easy, very easy. Okay, so here first we will arrange this number 5005 in such a way. Okay, so now here students 5 plus 5. So now here first we see that at the unit place there is a 5. So it cannot be divisible by 2. It cannot be divisible by 3 because the addition of the digit is 10. So it cannot be divisible by 2, 3, 4, but it could be divisible by 5. Okay student? So that means here students 5005 divided by 5. So here 5 ones are 5. So here 0, then here 0, then here 0, then here 5. So 5 ones are 5. So that means here student 1001. So I write here students 1001 and here 5. So now here 1001 students, the 1001 is divisible by, not divisible by 2. It could be divisible by 3. No, it cannot be divisible by 3, not 4, not 5, not 6. But whether we can check it is divisible by 7 or not. Okay, it is divisible by 7 or not. So here 1001 divided by 7. So 7 ones are 7 here. So here 3, then here 0, 7 fours are 28, then here 2, then here 1, 7 threes are 21. Yes, students, it is divisible by 7. So here I write here 143 and here 7. So now here students, we have the number 143. So is it divisible by this 143? Is divisible by 2? No. 3? No. 4? No. 5? No. 6? No. 7? No. 8? No. 9? No. 9? No. 9? It could not be. Then 11? Yes. It could be divisible by 11. So 11 ones are 11. And then here 3, 33. So 11 threes are 33. Yes. So here we say that 143 divisible by 11. So here we write here 11 and here 13. So now here students are 13. 13 is the prime number. So 13 ones are 13. So finally we write down the factors of 5005 is equal to 5 multiply 7 multiply 11 multiply 13. Okay. So these are the factors in the product form of their primes. Okay students, very easy example. You practice with me students, okay, then it can be very easy. So now here next one example students, see the next one example is 7429. It is a big number students, but we can solve it very easily. Okay, so 7429. Okay, so now here students, if you observe this number, then this number could be divisible by 3, could be divisible by 3. Okay, I check out whether it is divisible by 3. No, it cannot be. I better check out 7429 divisible by 3 or not. So 3 2s are 6 here. So 1, 3, 4s are 12. Okay, so 3 7s are 21. So it is not divisible by 3 students. So it directly divisible by 17 students. This number directly divisible by 17. So here students 7429. Okay. So here 17. So 17 fours are here. 17 fours are. So here 68. So minus then 6 here 0. Then 62. 17 threes are 51. Then here 1 1. Then here 1. So 17 sevens are 190. 0, 0. So here student 437. Okay, answer is 437. And I write here 17. So now here 437. Is it divisible by 17? No students. This number cannot be divisible by 17. It is directly divisible by 19. Okay students. So 19 2s are 38. So that's why here 5 and then 57. So 19 3s are 57. So here we say that we write here 23 and here students 19. Now here students 23. 23 is the prime number. So here 23 ones are 23. Okay students. And then we factorize this number as this way. Write this number as this way. 17 multiply 19 multiply 23. Okay. So this number is in the form of product of its prime factor. Let us see the second question students. Find the LCM and HCF of the following pairs of integers and verify that LCM multiply HCF is equal to product of the two numbers. Okay students, and the first example is 26 and 91. Okay students, so let us solve this example students. 26 and 91. So here first we calculate, we find out the factor of these each number 26 and 91. So here I arrange this pattern. Okay. So now here 26. First factorize 26. So at the unit place there is a 6. So 26 divisible by 2. So here I write 2. 2 ones are 2 and 2 threes are 6. Now 13 is a prime number students. So I write here 13 ones are 13. Okay. So students here the factor of the 26 is 2 multiply 13. Okay students. Now here students 91. Factorize the 91. Now here students at the unit place there is a 1. At the unit place there is a 1. So now here student this number could be divisible by 7. Could be divisible by 7. See here student 7 ones are 7. Then 2. Then here 21. Then 7 threes are 21. So here we write here 13 and here 7. So now here 13 is the prime number. So I write here 13. So 13 ones are 13. So this way we factorize this number. So here I write down 91 is equal to 7 multiply 13. Okay students, so now here first I calculate HCF and then LCM. So HCF, how can we calculate the HCF student? So as per our formula that the product of smallest power of each common prime factor. Okay students, product of the smallest power of each common prime factor. So here common power is 13 raised to 1 here also, 2 raised to 1 here, 7 raised to 1. So the common factor, which one is the common between these two numbers? That is the 13. And smallest power is the 1. So I write here 13 raised to 1. That means students 30. Okay, simply we write 30. So HCF is equal to 13. Okay, now here students the LCM. How can we calculate the LCM students? The LCM is the product of the greatest power of each prime factor involved in the numbers. Okay student, so product of the each number primes. So 2, 7, there are the numbers 2, 7 and 13. And we write the highest power of these numbers. So highest is here 1, here also 7 1 and here 13. So that means here 2 7s are 14 and 14 multiply 13. Okay, so here I do this calculation here 14 multiply 13. So here 13 4s are 52. So 5, 13 1s are 13 and 13 plus 5 that is 18. So 182 is the LCM of these two numbers. Okay students, now here we calculate LCM and HCM. Okay students, now there is a term to verify that LCM multiply HCF is equal to product of the two numbers. Okay, so here let us see the verification. Okay, so I do the verification here. I write down here verification. Okay, so verification, for the verification I write down the LHS. So what is the LHS? LHS, that is the left hand side, and left hand side is LCM multiply HCF. Okay students, LCM multiply HCF. So here LCM is students 182 and the HCF is 13. So 182 multiply 13. Okay, so calculate here 182 multiply 13. So here 3 2s are 6, 3 8s are 24. So 2 here, 3 3s are 3 and 4 5. So 0, here 2, 8 and here 1. So the addition of these 2, 6, 6, 3, 2366. Okay student, so I write here the product of LCM and HCF, that means here LHS is equal to 2366. Okay students, now here the right hand side. What is the right hand side students? That right hand side is product of the two numbers. Product of two numbers. Okay student, so what is the product of two numbers students? So the two numbers are 26 and 91. So here 26 multiplied by 91. Okay students, so now here I calculate here 26 multiply 91. So here students 6, 2, then 0, 54, then 18 and then 23. So here 2366. Yes students, so RHS is equal to 2366. Okay students, now here students see here students that the LHS are here LHS and RHS. See here students that LHS and here students this RHS are equal. Okay students, that means it is verified. Okay, so here we say that therefore LHS is equal to RHS. That it means it is verified. It is verified. Okay students, so this way we can solve this such a type of the example. Okay students, now here the next one example student, see the next one example. The next one example is for the two numbers 510 and 92. Okay, so first our process is to calculate the factors of these two numbers. So let us calculate factors of these numbers. Okay students, yes, so I write here 510 first. Arrange this number here and here 92. Okay students, then here students 510, in this 510 students at the unit place there is a 0. So this number 510 is divisible by 2. So here 2, then 2 2s are 4, here 1, then here 1, 2 5s are 10 here, then here 1, here also 0, then 2 5s are 10 here. Okay, students? So now here this way, we get 255. So I write here 255 and here 2. Now here students, we get the 255. So the at the unit place there is a 5. So it does not divisible by 2. This number does not divisible by 2. So it could be divisible by 3. Why it could be divisible by 3 students? Because 2 plus 5 plus 5 and that is equal to 12. Okay students, so 12 is divisible by 3 students. So that means 255 automatically divisible by 3. So 255 divided by 3 students. So 3 8s are 24. So here 1, then here 5. So 3 5s are 15. Okay students. So now here we get 85 here. So 85, I write 85 here and 3 here. Now here students, 85 do not divisible by 3 students, do not divisible by 4, but it could be divisible by 5 because at the unit place there is a 5 digit. Okay, so here 85 divisible by 5. Okay students, so 5 ones are 5. So here 3 and here 5, so 5 sevens are 35. So here minus here 0. Okay, so now here I write here 17 students and here students I write 5. Okay, now the 17 is a prime number, so I write here 17 ones are 17. Okay, and I write the factor of the 510. So here 2 multiply 3 multiply 5 and multiply 17. Okay student, these are the factors of 510. Now the term of 92. So factorize the 92. So now at the unit place there is a 92. At the unit place there is a 2. So this number is divisible by 2. So here I write 92 divided by 2. So 2 4s are 8. Here then 12. So 2 6s are 12. So that means here students I get here 46. So I write here 46 and here 2. Now here at the unit place there is a 6. So this number is divisible by 2. So here 46 divided by 2. So 2 2s are 4 and 0 here 6. So 2 3s are 6. Okay student. So here we get 23 and here 2. So now 23 is a prime number. So we write 23 ones are 23. Okay student. So the factor of 92. So now here students I write the factor of 92 here, which is equal to 2 multiply 2 multiply 23. Okay students, that means I write here square of 2 multiply 23. Okay students, multiply 23. And as well as students, we can write the power of these numbers. Okay, so here power of these numbers is 1. Okay, such a way we write the factor. Now here now the second process is that we have to calculate the LCM and HCF. Okay students, we calculate the LCM and HCF. So now here first we calculate students HCF. Okay, so what is the formula to calculate the HCF? That means the product of the smallest power of each common prime number, okay, or common prime factor in the number. So common prime factor is students here 2. Okay, here in between 510 and 92 the common is 2, and the smallest power is students in between this number, that is the 2 raised to 1. Okay, so I write here 2. So HCF is students 2. Okay, we get the HCF as 2. Then calculate the LCM students. Now here calculate LCM students here, LCM. Okay, so how can we calculate LCM students? That is the product of the greatest power of each prime factor involved in the given number. Okay, so which one is the numbers? Each number, so there are the numbers 2, then 3, then here 5, then here 17 and then 23. So the product of each primes and having the highest power students, having the highest power. So highest power of 2 is 2. So I write 2. And the highest power of 3 is 1. 5, 1, 17, 1, 23, 1. Okay, so that means here students that square of 2, that means here 4 students. Then here students 3 5s are 15. Multiply, now here 17 multiply 23. 17 multiply 23 students. So that means here 21, 3, 4, 5, students 0 here, then 14, then 2, and then 3. So that means here 1, 9, 391. Okay. Now here students, the product of these numbers students, that is the 60. Okay. Then multiply 391. So here 391 multiply 6 students. So that means 6, then here 54, then 5, 54, and then here students 18, and 18 plus 5, that means 23. So 2346. Okay student. So LCM is 2346. Okay students. And here also here student 0. That means here we place here 0. Okay students. This is the 2346 is the product of only 391 multiply 3. Okay. But here is a 0. So I write here 0. So the number is, the LCM is 23,460. Okay students, get this point. Now here students, our next process is for the verification. So see the verification students, here I write down the verification. So verification for LHS is that product of LCM and HCF. Okay students, so product of LCM is 23,460 and HCF is 2. So here product of these two, that is 23,460 multiplied 2 here students. So here 0, then here 12, then 8, 9, and then here 46. So 46,920. Okay students, so LHS is 46,920. Okay, now the turn is for the RHS. So here we draw the RHS students here. Okay, so RHS here. Okay, so RHS is that for product of two numbers. Okay, product of two numbers. Product of two numbers. So which are the two products, two numbers students? 510 and 92. So 510 multiplied by 92. Okay students, so I do here 51 multiplied 92. Okay, so now here 2, then here 10, here 0, then here 9, then here 45. Okay students, so addition of these two, 9, here 6, 4. Okay students, so which is equal to 46,920. Okay students, 46,920. So here see, observe students, that is LHS and RHS both are equal. Okay students, LHS is equal to RHS. So I write here students, I write here therefore LHS is equal to RHS, and therefore we can say that it is verified. Okay, it is verified. It is verified. Okay students, so such a way we can solve this process by easy step. Okay student, this is a very easy step, easy way, easy method to solve this verification students. Okay, such a type of the examples. Okay, so now here the next one example students, let us see the next one example. Yes, so the next one example is students 336 and 54 for these two numbers. So here first we have to find out the factors. Okay, so I first find out the factors of 336 and for 54. Okay students. Yes, so now in 336 at the unit place there is a 6, so it could be divisible by 2. Okay, so 336 2, so 2 ones are 2 here, 1, then here 3, 2 6 are 12, and then here 1, then here 6, so 2 8s are 16. Okay students, and that's why here I write 168 and here 2. Now in 168 at the unit place there is a 8, so it is divisible by 2, so I write here 168 divided by 2, so 2 8s are 16, and here students 2 4s are 8. Okay students, so now here I write here 84 and here 2. Now 84 at the unit place there is a 4, so it is divisible by 2 also. Okay student, so 2 4s are 8 here, and then 0, then here 2 2s are 4, and then here the number is 42. So I write here 42 and here 2. Now 42 also divisible by 2. So here 42 divided by 2, that means 2 2s are 4, then 0, and there 2, so 2 ones are 2. Okay student, so 0. So here I write here students 21 and here 2. So now here 21. So the 21 do not divisible by 2, it divisible by 3. Okay, because it is in table 3. So here 3 7s are 21 and 7 is the prime number. So I write here 7 1s are 7. Okay student, so now here I write down the factor of 336 is equal to 2 multiply 2 multiply 2 multiply 2 multiply 3 multiply 7. Okay student, so that means I write here 1 2 3 4. So 2 comes at the 4 times. So I write 2 raised to 4 multiply 3 raised to 1 multiply 7 raised to 1. Okay, 336 such a way. So now here the turn for the 54, first we factorize the 54. Now 54, 4 at any place there is a 4. So 54 divided by 2. Okay, 54 should be divisible by 4, 2. So here 2 2s are 4, then here 1, then 14, 2 7s are 14, then here students 27. So I write here 27. Okay students. Then here 2. Now 27 do not divisible by 2 students, it is divisible by 3. So I write here 3. So 3 9s are 27. And here students 3 3s are 9 and then 3 1s are 3. So such a way we factorize the 54. So I write the 54. Okay, I write the 54 here students. See, at this bottom I write 54. So 54. Okay students, I write here the here. Okay, 54 is equal to 2 multiply 3 multiply 3 multiply 3. Okay students, this way. And then here students, as well as we can write 54 as 2 raised to 1 multiply and 3 comes 3 times. So cube of 3 students, cube of 3. Okay, so such a way we factorize the two numbers 336 and the 54. Now there is a process or there is a step for calculating HCF and LCM. Okay, so calculate the HCF first. So here HCF. So now here HCF. Now we are familiar for the formula for the HCF, that is the product of the smallest power of each common prime factor. Okay students, so common prime factor, common is, which one is the common? 2 is common here in both the number, 3 is common student. So I write the 2 and 3 here, product of these. Okay, but which power we taken here? We taken the smallest power of the 2 and 3. The smallest power of 2 is students here 1. So I write here 1. And the smallest power of 3 here students, the 1 also. So I write here 3 raised to 1. So the product of 2 raised to 1 multiply 3 raised to 1, that means here 6. So here students, HCF is equal to 6. Okay, HCF is equal to 6. Okay students, this is the proper method of the class 10 CBSE or NCERT students. Okay, so now we have to calculate for the HCF and the LCM. Okay, to calculate HCF and LCM, this is the specific or the proper method. Okay, so learn this method students. Now student, let us calculate the LCM students. So the LCM formula is that the product of the greatest power of each prime factor involved in the numbers. Okay, so here the involved numbers are students 2, 3 and 7. Okay, now here product of these factors of the greatest power. So the greatest power in between the 2, that is the 4. So I write here 2 raised to 4. Greatest power of 3, here cube. So here I write 3 and the 1. Okay, for the 7 it is 1. So now here 2 raised to 4. So 2 raised to 4 means 2 2s are 4, 4 2s are 8, 8 2s are 16. So here I write down 16. Now 3 cube. So 3 cube means students 3 3s are 9 and 9 3s are 27. So here I write down 27 multiplied by 7. So now the product of 16 and 27. So here 7 6 are 42. Then 7 7 and here 11. So here 0, then 12, here 1, 2 and then 3. Okay. So now here 2, 3. So 432 multiplied by 7. Okay students, 432 multiplied by 7. So now here 432 multiplied 7. So 7 2s are 14. So 8, 21, 22, then 28 and then 30. So 3024. So the product of 432 and the 7 is 3024. So that's why LCM is equal to 3024. Okay students. So verification, first we verify the LHS. So LHS is the product of LCM and HCF. So LCM multiply HCF student. So here LCM is 3024 and the HCF 6. So now here product of these two numbers, I do here students 3024 multiply 6 students. So here 6 4s are 24, then here 12 and then 14, then here 18. So 18,144. Okay students, LHS is equal to 18,144. Okay, so now here students the RHS. Now here students the RHS. Okay, so I write down here the RHS. So RHS is equal to product of two numbers. Product of two numbers. So two numbers are students 336 multiplied here multiplied 54. Okay students. So here I do the calculation here 336 multiplied 54. So here 24. So here 14 1 12 13 then 0 then 30 here students then 15 18 then 15 here 16. Okay students. Then here 4 4 then here 11, so 6, 7, 8, so 18,144. Okay, so I write here RHS is equal to 18,144. So now here students observe LHS and RHS both are equal and that is equal to 18,144. Okay students, so here we write that LHS, therefore LHS is equal to RHS, and that means students here it means it is verified. It is verified. Okay students, so such a way we can solve such a type of the example students, and stepwise it is a very easy method students. You follow this method. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay, so students the three numbers are 12, 15 and 21. Okay, so here we have to find out LCM and HCF of these numbers. So now we factorize one by one these numbers 12, 15 and 21. Okay, so I arrange this way. Then here students, okay, so now here 12, we'll factorize first the 12. So here 12 means it is divisible by 2, so 2 6 are 12, then 2 3s are 6, then here 3 1s are 3. Okay, so I write here 12 is equal to 2 multiply 3, and that means here students square of 2 multiply 3 raised to 1. Okay, so these are the factors of 12. Now factorize the 15 students. 15 it is divisible by 3, so 3 5s are 15. Now the 5 1s are 5. Okay, so now here 15 is equal to 3 multiply 5. So I write down the factor of 15 here. And then student the 21, factorize 21. 21 is divisible by 3. So 3 7s are 21 and 7 1s are 7. So here I write the factors of 21. So 3 multiply 7. Okay students, then here I find out the LCM. Okay, first I find out the LCM. So here I write down first I find out the HCF students. It is very easy. HCF, that means the common factor in between these factors. Okay, so now here students see here is a 3 raised to 1. So 3 is the common factor in between these three numbers. So I write down the HCF as 3. Okay, HCF as 3. And then students the LCM. Okay, LCM. So now LCM, that means the product of the greatest power of each prime factor involved in the number. So now here each number first I write down the each number involved in these numbers. So there are 2, 3, 5 and 7. So I write down 2, 3, 5, 7 and make the product of them. Okay, write down the product of them and write down the greatest power of each number. So the greatest power of 2 is 2, so I write down here 2. The greatest power of 3 is the 3, so I write down here 3. And the greatest power of 5 is 1, so I write down here 1. And the greatest power of 7 is the 1, so I write down 1. So now here product of these. So now 2 raised to 2, that means square of 2, that is equal to 4. So now here that is 3 5s are 15 and 15 7s are 105. So now here 4 multiply 105, that means students that 420. So LCM is equal to 420. So such a way we can find out the LCM and the HCF by the by applying the prime factorization method. Okay, students, so this is a proper method that you can calculate the HCF and the LCM. It is very, very easy method, students. Okay, so now let us see the next one example, students. See the next one example. 17, the numbers are 17, 23 and 29. Okay, first we factorize these numbers. First here I write down the number 17, then here 23, then here 29. So now here if you carefully observe these numbers, students, if you carefully observe these numbers, then these numbers are the prime numbers, students. These numbers are the prime numbers. So it is very easy to factorize these numbers. That means here 17 ones are 17, here 23 ones are 23, and here 29 ones are 29. Okay, very easy because these numbers are prime numbers. Okay, so now here I write down 17 is equal to 17 multiply 1. Here 23, I will write down the factor 23 ones are 23. Okay, students, and then here the last one, that is the next number 29 is equal to 29 multiply 1. So now here students, finding out the HCF first. So here HCF, and that HCF means the common factor in between these three numbers. So the common number is that the 1. So HCF is equal to 1. Okay, student, HCF is equal to 1. So now here student, LCM, the LCM here students, LCM. So LCM is equal to, first write down the different number. So different numbers are 17, 23 and the 29. Okay, and then product of them, the greatest power of each prime factor. So 17 raised to 1, 23 raised to 1 and 29 raised to 1. That means it said 17 multiply 23 multiply 29, student. So now here I multiply 17 multiply 23 here multiply 23. So that means here 21, 3, 5 here, student 0, then 14, then here 1, 2 ones are 2 and then 3. Then here 1, 9 and 3. So 391 multiply 29. Okay, 391 multiply 29. So here students, 9 ones are 9, 81, then here 27 and 27 plus 8, that means here 35. Then here 0, then here 2, then 18 here, then 3 2s are 6 and then 7. Okay students, so then here 9, 3, 3, here 10, 11. So now here students, 11,339 is the LCM of these three numbers. Okay, so this is very easy and the proper method to solve these LCM and HCM. Okay students, then next one example students, see the next one example, 8, 9 and 25. Okay, find out the LCM and HCM by the prime factorization method. Okay, prime factorization method. So first I write down students here 8, then here 9 and then here 25. Okay students, and then here I factorize the first number 8. So 2 4s are 8 and then 2 2s are 4 and then 2 1s are 2. So that means here I write down 8 is equal to 2 multiply 2 multiply 2. That means I write down 8 is equal to cube of 2. Okay, cube of 2. Then here 9, that means 3 3s are 9. Then here 3 1s are 3. So I write down the factor of 9 is equal to 3 multiply 3, and that means students here 9 is equal to square of 3. Okay students, and then here students the 25, factorize the 25, that means 5 5s are 25 and then 5 1s are 5. Okay students, and then that means here 25 is equal to 5 multiply 5, and that means here 25 is equal to square of 2. Okay students, now here student, first we finding out the HCF. So here HCF, finding out the HCF students here. So HCF is equal to the common factor in between these. So here no one is the common in between these three numbers. So that means here that common prime factor is the 1. Okay, common prime factor is the 1. So I write here HCF as 1. Okay students, and then finding out the LCM. Okay, then finding out the LCM. So here LCM is equal to write down the involved number. Write down the involved number. The involved numbers are 2 3 5. 2 3 5. That means that is the product of the greatest power of each prime factor involved in the numbers. Okay, so that means product, and then write down the highest power or greatest power of these numbers. So the greatest power of the 2 is 3, greatest power of 3 is 2 and the greatest power of 5 is 2. So that means here I write down this cube of 2, square of 3, multiply square of 2, 3 and multiply square of 5. That means here the 2 raised to 3, that means cube of 2, cube of 2. So that means 2 2s are 4, 4 2s are 8. So I write down here 8 and then square of 3, that is 9 and the square of 5, that means here 25. Okay students, then 8 9s are 72. Then here multiply 25. So now here 72 multiply 25. So that means here students 10, then here 36, then here 0, then here 4 and here 14. So that means here students 0, then here 10, 1, 8, then 1800. Okay student. So LCM is equal to 1800. LCM is equal to 1800. Okay. By applying the prime factorization method, we can calculate such a HCF and the HCF if there are the three numbers are given. Okay. Given that HCF of the two numbers, that is HCF of 306 and 657 is equal to 9. Find LCM of 306 and 657. So now here students, given is that, first we write the given. Okay. So what is the given here students? That given is HCF is equal to 9. Okay. And the first number students here, first number is equal to 306 and the second number is equal to 657 and we have to calculate students the LCM. So I write down LCM is equal to question mark. Okay students, so now here these are the quantities and related with this quantity HCF, LCM, first number, second number, there is a formula and that formula is students, that formula is that the HCF multiplied LCM is equal to first number multiplied second number. So here I substitute these values in this formula students, in this formula. So the HCF, that HCF is equal to, or we can change the formula, we can modify this formula as students, that here LCM, because we have to calculate LCM, so LCM is equal to first number multiplied second number divided by this HCF. Okay students, so this is the new formula. Okay, we modify of the original one. So now here LCM is equal to, so now here substitution students, first number, see the first number, that is 306. So I write down 306. Multiply here second number, so second number here students 657. So I write down here 657 and the HCF, that HCF is 9. Okay student, so now here 306 divisible by 9 or not. So here 3 3s are 9. Okay students, so 3 1s are 3, 0 and 3 2s are 6. Okay students, and then here again that I write down 3 1s are 3, 3 3s are 3 and 3 4s are 12. Okay student, so the final answer, that means here students, we write down LCM is equal to 34 multiplied 657. So here I calculate this, here 657 multiply 34. So here 4 7s are 28. So for 20, then 22, then here 6 4s are 24 and then 26. Then here 0, then here 21, then 15, 17, then 18, 19. Okay students, so the addition of these 8, 3, then here 3, then 10, 12, here 20. So 22,338 is the answer. So here I write down LCM as 22,338. Okay. So such a way, by using this formula, we can calculate the LCM. Okay student, as well as we can calculate the HCF also. Okay student. Then the next one example. Okay. See the next one example students. See. Check whether 6 raised to n can end with the digit 0 for any natural number n. Okay. So now here students, here is a verification student. This is the verification and this verification is for students for the number that is the 6 raised to, that we have to check out that whether 6 raised to n can end with 0, can end with the digit 0 or not. So now here if we say that 6 raised to n, here students, I write down that 6 raised to n can end with can end with the digit 0. End with the digit 0. If 2 and 5, if 2 and 5 both, that 2 and 5 both are its prime factors. Okay, both are its prime factor. Okay, so this condition is applicable. That is 6 raised to n can end with the digit 0 when 2 and 5 both are its prime factor. Otherwise not. But now here the 6 raised to n, the number is 6 raised to n. So we factorize that number. That is 2 multiply 3 whole bracket raised to n. That means here students that 6 raised to n end with the both numbers 2 and 3. Both numbers 2 and 3 of its prime factor. We get the 2 and 3 as a prime factor. Okay, student. So that means here 2 is there. 2 included in this 6 raised to n. Factorize of the 6 raised to n. But the 5 not included in that. So that means here students. We can say that 6 raised to n. I write down that 6 raised to n end with 6 raised to n have 2 and 3 are its have 2 and 3 as a prime factor, as a prime factors. Okay, 2 is included, but 5 do not included as a prime factor, That means students, therefore 6 raised to n cannot end with digit 0. Cannot end with the digit 0. Okay, students. So now here such a way we can solve, we can check out or we can verify out whether 6 raised to n or any number can end with the digit 0. Okay, student. So now here explain why 7 into 11 into 13 plus 13 and 7 multiplied 6 multiplied 5 multiplied 4 multiplied 3 multiplied 2 multiplied 1 plus 5 are a composite number. Okay, students, these are the two numbers and we have to show out these numbers are the composite number. So one by one we have to show out these numbers are the composite number. How? So see here students, observe this carefully. How can we check out or how can we verify these numbers are the composite number? So first I write down the first number 7 multiplied 11 multiplied 13 plus 13. Okay, now here students see 7 multiplied 11 multiplied 3. So these numbers are in the product form and here this number is in the addition form. So here we get the common. So 13 is the common and then here we write 7 multiplied 11 multiplied 1 plus here 1. Okay, students. So this way we arrange this number. Okay. So now here students the 13 and then in the bracket that's 7 multiplied 11, that means here students 77 and here plus 1. So that means here 13 multiplied here 78. Okay, 13 multiplied 78. So now here students 13 is a prime factor. So I write down as it is. And then 78. So 78, I factorize that 78. That means here 2 multiply. Here 2 3s are 6, 2 9s are, that means 39. So 39 multiplied, then here 13 multiplied 3 multiplied 2, 39. And write the factorization of 39 as this here. 13 multiplied 3. Okay, students, here. So I arrange this number 13 multiply 3 multiply 2. Okay, so now here students observe this factor carefully that there are the factor 2, 3 and the 13. That means here more than the or other than one factor. Okay, it included other than one factor or itself. Okay, so that means it is a composite number. Okay, students, it is a composite number. So here first I write down that here it is a composite number. It is a composite number. And also I write down the reason because why? So here because this number have other than 1 factor. So now we are seeing there are the more than 2 factor. So that means these are a composite number. So this number have other than 1 factor. Okay. So now here let us see the second one. That second one is also a composite number. We have to check out that here second number. That means here 7 multiply 6. Here multiply 5, multiply 4, multiply 3, multiply 2 and multiply 1 plus 5. Okay students, so now here students observe these numbers carefully. Now here these numbers are in the product form. These numbers are in the product form and this 5 is in addition form. So here students, here is a 5, here is a 5. So here from both the numbers, from both the terms, we common out that is the 5. Okay, so 5 in the bracket 7 multiply 6 multiply 1 multiply 4 multiply 3 multiply 2 multiply 1 plus 1. Okay, so such a way we arrange the number. Then here 5, then here that is these are the numbers. So here 7 6 are 42. Okay, then multiply here 4 3 are 12, 12 2 are 24. Okay, and then plus 1 here. So now here 5 in the bracket, that means here 42 multiply 24 plus 1. So here 42 multiply 24. That means here students 8, 16, 0, then 4, 8. So 8 here, then 8, 9, 10. Okay. So 1008 plus 1. Okay student. So that means 5 multiplied 1009. Okay student. 5 multiplied 1009. Okay. So now here students that 1009 and the 5. So these are the factors other than 1. Okay. These given number having the factor of 1 other than 1, that is 5 and also 1009. So that means it is also, therefore we say that it is a composite number. It is a composite number. Okay students, you can write out, separate out such a way, or we can combinedly write down the result here that these numbers are composite number because these numbers have other than 1 factor, or you may write down the separate as I write down. Okay, so now because these number have other than 1 factor, other than 1 factor. Okay student, so such a way we write down or we verify that the given numbers are the composite numbers. Okay. Next one example students, 7th one example. There is a circular path around a sports field. Sonia takes 18 minutes to drive 1 round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Okay students, so now here students, this is clear that we have to calculate, that is after that they will meet again at the starting point. That means here we have to calculate the LCM students. Okay, we have to calculate the LCM of the 12 minutes and the 18 minutes. Because students, that Sonia takes the 18 minutes that to drive 1 round of the field, and that's it, that at that same time that Ravi takes 12 minutes. Okay students, and we have to calculate the minimum time, they will meet again. That means here we have to calculate the LCM. Okay students, so it is very clear that we have to calculate the LCM of 12 and 18. Okay, so here I write down that here that Sonia and Ravi will meet again at starting point Sonia Ravi will meet again at starting point is equal to question mark. Okay, and given that Sonia takes time which is equal to 18 minutes and then Ravi takes time is equal to 12 minutes. So that means here students, I write down the minimum time, or at the minimum time they will meet which is equal to, which is nothing but to calculate LCM of 12 and 18. That means to calculate LCM of 12 and 18. Okay students, so now here the process to calculate the LCM, that means I first factorize the 12. So here 12, that is 2 6 are 12, 2 3 are 6, 3 1 are 3. Okay, so the factor of 12, 2 multiply 3, that means therefore 12 is equal to square of 2 multiply 3 raised to 1. Okay students, and then here the 18, factorize the 18 students here. So 18, that means here 2 9s are 18, then 3 3s are 9, then 3 1s are 3. So I write down here 18 is equal to 2 multiply 3 multiply 3. That means here 2 raised to 1 multiplied square of 3. Okay. Therefore 18 is equal to 2 raised to 1 multiplied square of 3. Now here LCM, we know that how can we calculate the LCM? Okay students. So here I write down LCM. So LCM is equal to, LCM is equal to the product of the greatest over each prime factor involved in the numbers. So now here each prime factor involved in the number are 2 and 3. So I write down the 2 and 3 and their product. And the greatest number, that means the square of 2, greatest power of 2 is the 2 and greatest power of 3 is the 2. So that means here square of 2, that is the 4, square of 3, that is the 9, and here 9 4s are 36. So the LCM is equal to 36. And as the LCM is 36, students, as the LCM is 36, I write down that therefore they will meet, that Sonia and Ravi will meet again at starting point, after 36 minutes. So this is the final answer. Okay students, this is the final answer. Okay, so such a way the exercise 1.1 completed. Okay students.